preparing for life. Okay, so take got it. Yeah. Okay. Before we start, don't forget to click the attendance list. Yeah, can you check your attendance list?
Yes, doctor.
Okay, preparing for life. Okay, so share and I will give the link to you here. Set. Are you 2020? 19, right? Okay, I used to screen. Wait a while. Okay, good. Yeah, so continue to the context of the video. Yeah, this is about the static electricity. Wow.
Good morning,
What is
children. Today we shall learn about charging and discharging of objects. If you try to put on
you
a
can
woolen
rubbing
sweater while
head.
your hair is dry, your hair will stand straight. Do it in the dark and you may see a small spark and hear a crackling
Hey,
sound.
have you an experience rubbing your hair? I have an equipment in the lab. Van der Graaf generator. Van der Graaf generator. Yeah, I will show you later.
This phenomena is actually same as
Okay.
lightning.
My questions. Why, when we are rubbing our head, so our hair becoming, look at, go straightly? Would you please give us the reason? Have you ever seen the evidence? If you go to Kota Baru Parahyangan, you can try yourself rubbing your or contacting your hand to the Van der Graaf generator. Here. Van. Oh, sorry. You will see here. Oh, wow, this one. Here. Long hair.
Hi everyone,
You heard
I'm
the
here at
sound?
the University of Sydney today. I've got one familiar face, Peter, over here.
How's it going?
And this
Okay,
is Dave and
so-
Liam. So everyone here is interested in, I guess, physics education.
And all those kind of things. So that is,
10 or 15 centimeter gap.
We'll take 10.
so
Yeah, I'll say
yeah,
10.
that's a lot of volts. Someone
look
do
at
the math quick. I'm not good at this.
Look here. Make it.
Alrighty.
Wow, that's
Anyone
dry.
want to demonstrate
Wow.
or I'm up first?
You're up first.
Okay,
Alright.
I'm standing
Stand
on
on
here.
it. Yep. I'd maybe take your watch off. It's normally totally safe, but
Yeah.
I'm more worried about breaking your watch than
Yeah.
hurting you.
Okay, you're discharging it?
I'm just charging at the moment, so what you'll need to do now, hit the ground, so in order to build charge, hands on.
Hand on now.
Both hands, both hands is best. It's good at the moment. I'm going to now take the earth off.
Yeah.
There we go.
So you should feel anything.
I don't feel anything.
But you can see the
Except
strands
fear.
there.
Yeah. I think you can start to see your hair moving.
Yeah, hair's
Yeah,
starting to
yeah,
move
yeah.
already.
Can you give your hair a shake?
Yeah. Give it a shot.
And in particular,
Oh my god, that's amazing!
How does it look?
That's so cool!
Cameraman, how is it?
Look her hair here.
Are any of the longer strands like...
they are, like
The-
these ones are starting to
Affected?
push out a little bit. Yeah,
I don't know if you can get all my hair in the frame.
This shouldn't hurt you.
Shouldn't.
So I might be able to convince somebody.
Okay, so my question is, look at when she contacting, her hair, her hand to Van der Graaf generator, you will see his hair affected by Van der Graaf generator. Yeah, my question is, can you release your hand from the Van der Graaf generator directly during charging? this is my question. What will happen if she release her hand directly?
I think
Hair would just fall down.
Mm-hmm. And then from Sri Rahma,
I think she can, sir.
she can. Okay, so the other. You can try it at lab. Okay, so the answer is you cannot release your hand directly. Yeah. So look at the beginning. Before she contact her hand, the professor discharge it first. Look at they contact this one. Yeah, in order to make it the voltage 0. Look at here. Can you see this one?
Yes.
This is in order to discharge. Yeah, discharge. And afterward, she contacted her hand to a Van der Graaf generator. So she didn't electrify. Yeah. But the questions, if she directly release her hand, pull out her hand from the generator, it will be directly electrified because the voltage it's almost 200 volt. 200 volt. Yeah. But see where, look at here. Yeah. So it can make the electricity didn't flow through the ground. Okay. So the evidence will be make it different if the professor didn't wear these cloths. Yeah, this is the cloths or woods. Yeah, in order to prevent electrifications. So the static electricity make her safe. Okay. So another phenomenon I want to show. Is there any question from you?
I do actually. I always
Okay.
want to
So
know.
please.
Okay, so when you rub your, let's say, hair with an object, there's electric charge. Like, what I want to know is that how does the action of rubbing itself, action of friction, causes
Okay.
electric charge?
Okay. So would you please give the hypothesis why during rubbing your head, by what's the name? What kind of material you commonly use for rubbing your head?
Let's say your hair and your like piece of plastic.
Okay, so using a plastic, okay, look at here. Why don't birds get electrocuted? Yeah, in the transmission line. Look at here. It's the
Would you ever
question,
touch
right?
a live electrical wire?
Whoa! Look at.
Of course
Whoa.
not, because it is likely to kill you. So how come birds can sit unruffled on high voltage power lines? What magical ability do they have to withstand such contact? To understand that, we must first understand electrical current. Electrical current is the movement of electrons.
Look at it happen when you are racing to contact the device and directly electrified. Yeah. So because of potential difference. Yeah. When there is a potential difference, so it make electrifications. Okay. Look.
These electrons travel from the power station to your house through the mains. They then move through the power lines, through your electronic devices, and eventually return to the mains. This process takes place in a closed loop. This closed loop is necessary in order for electricity to flow. In order to move, electrons also require a difference in electrical potential. Simply put, electrons move from a higher electrical potential to a lower one. Imagine a bunch of balls on top of a hill. If they are not blocked, they will roll down any path that becomes available. This is similar to how electrons move from one electrical potential to another. But when a bird sits on a wire, both of its feet are at the same electrical potential, so the electrons therefore have no reason to flow through the bird's body. No moving electrons means no electric current. The bird is safe unless it suddenly touches another electrical wire, especially one with a different electrical potential. If it does this, it opens a path for the electrons to flow, a path for electrons to move through its body. It is also dangerous for birds to sit on the wooden pole supporting the wires. This pole is buried in the ground, so it has a low electrical potential. If a bird were to sit on that pole and simultaneously touch a wire, the current would once more flow from the high potential wire through the bird's body and into the low potential ground. This is the same reason why it is dangerous for humans to touch live wires.
So the question, why the bird is not electrified when contacting to the electrical line? Would you please give the reason as you watch the video? Nabila. Okay, Nabila.
Yes, sir. Because the bird is not directly connected to the ground.
Okay, so what happened when the bird do not contact with the ground?
There is no so the electrical power is not stay in the bird or
So what does it mean, the term? Maria, would you please support Nabila? So, and Maria, would you open your video so I can see your appearance?
Actually, this is mati lampu, sir.
Okay, so would you please support Nabila's answer?
I think because
why the bird not electrified?
Yeah, because in the bird there is no electron. Bird doesn't have the electron that can menghantarkan listrik.
Okay, so another opinion,
May
still
I-
not
can
in
I,
the
sir?
exact answer.
Can
Abi,
I,
okay,
sir?
please, Abi, yeah.
Because the bird is not touching the ground, sir.
Okay, so yeah, in fact, the bird is not touching the ground, but in terms of the concept, which concept you apply?
Electric potential.
Okay, so there is no electric potential across
Bird's feet.
bird's leg. Yeah, look at, yeah, bird's feet. Yeah. So look here, the bird contacting the same wire. Yeah, bird contacting the same wire. So there is no potential difference across two legs here because two bird leg contacting the same wire. So that the bird do not electrified. It's not electrified. The evidence will make it different when the bird stand. Yeah, look at here, this one. Yeah, maybe there is potential for the bird to contact the ground, because look at here, it is contacted to the ground. Yeah, when, for example, the wire, not all of the wire peel the wire, not coated, some wire also coated, coated wire. A wire is made of copper, but in fact also some wire in the high transmissions line, there is no here, it is not here, this is non-coated wire. What does it mean? This wire, there is no insulator coating the wire, so it make it dangerous. Which one? Okay, so okay, here, I need here how to see. I need the annotations, so how to show the annotations? Can you hear my voice?
Yes, sir.
Yes.
Okay, sorry, I lost. Where is the Zoom? Sorry. Okay, I'm waiting. I need my link. Oh, here. Okay. So, yeah. So I need to share my screen again. Here, when the bird stand, yeah, in these positions, yeah, the bird has the high potential to be electrified because two bird leg contacted with the different material. Yeah, but when the bird, stand on the line, bird will not be electrified. Yeah. Okay. Yeah. Okay, I will show another video. Maybe the video will be useful. So this is a video. Here. Yeah, this is another
Acquired some
example.
charges because of rubbing with dry hair. So now the comb is a charged object. The comb attracted the pieces of paper because charged object attracts uncharged object. In the process of charging the plastic comb,
My question is, look at what is the plastic what's the comb made of? This the comb made of plastic, right? This is made of plastic.
Yes.
Okay. My question is, when you use the steel, maybe some comb made of steel or another material made of steel. Okay, my questions, when you are rubbing to your hair, okay, can you see the attraction toward the paper? You have this experience previously?
Yes.
Yes.
So what will happen if you use the steel comb?
The paper doesn't attract with the comb when we use steel.
Okay, the question is, why the paper cannot attract?
Because the charge is same, but when we use plastic comb, when we rub with our hair, the plastic comb will negative charge, so the paper will attract with plastic comb.
What is the meaning of charge in this condition? Do you say the charge will become negative or the charge is positive?
Charge should be the presence or lack of presence of electrons.
So what is the electrical properties of plastic? Is it a conductor or insulator?
It is an insulator.
So what make it different, conductor and insulator, when you are rubbing to your hair? Look at, this is the example, right? When you are rubbing your comb to your hair and afterward interact it with the paper, so the paper can be attracted by the comb. Okay. Yeah. But if you use the steel comb or the iron comb, yeah, your hypothesis, you can try. Yeah, that's the problem of pandemic. Yeah, I cannot show it you directly, but you can try it. The comb will be made of the steel. So what will happen if it is steel? The steel will what? Okay, so in terms of how hard and how easy the electron move. So what is the different steel from the plastic?
Electron in metal or conductor is more stable, so the electron is
What do you mean stable?
more likely.
So what's make it different, stable and unstable? What does it mean? So this is steel and this is plastic. Okay, and you are rubbing it. Yeah, this a piece of paper you want to interact. Yeah, this also a piece of paper that you want to interact with each other. So when you are rubbing it through your hair, this side, just draw your hair. Okay, this also we are rubbing through your hair. And what would you please can you make an annotations? So how does the distribution of the electron in the steel and in the plastic? This example we here okay, this your hand. Okay, this your hand. We are yeah, this your hand. I my hand, and this also yeah our hand. Okay, okay. We hold it by the hand. It is our hand. Okay. So how the electron move? This firstly electron coming from your hair. This is your hair, right?
Yes.
This is your hair. Okay. So what does it mean here? What is the phenomena of your rubbing your comb to your hair? We call it as inductions, electrical inductions. Yeah, so electrical inductions. Yeah, you induct. And afterwards, yeah, here a plastic, and this one is steel. Yeah, when you make the inductions, so what will happen? Firstly, it will be neutral. Firstly, it is neutral, right? The same case as the steel. Firstly, it show neutral. Yeah. Okay. When you are inducted here, what will happen? This electron will make the proton interact, right? This one. Okay, it will interact the proton inside. Yeah. So the electron, okay, the proton inductions, yeah, electron contacted with the proton. In fact, it's not proton. Okay, so you can imagine the proton and the electron size was different because proton look like here. If we imagine it's the basketball, and also electron like here a green bean, yeah, but the charge is the same. This first and was negative. It's different from its sign. The charge will be 1.6 times 10 to the power of negative 19 coulomb, right?
Coulomb, yes.
Okay, so it show first is basket, and afterward here electron like a green bean. So firstly the electron, okay, in pair in this, yeah, during a neutral conditions, but afterward you make the induction to the hair. So afterward electron from the comb here, okay, repulse, yeah, repulsed by the electron in the air. So afterward electron move to this one, negative, 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 negative. Okay, because it is plastic, yeah, the electron movement, it didn't move, yeah, too long, yeah, it just stay on the plastic. So electron stay, yeah, in the surface of the plastic, yeah, of the plastic. Okay, could you imagine? Okay, this the mechanism. But in fact here the steel material is different
Hello, sir.
Can you hear my voice?
Yes.
Okay, so maybe it's it's not good to show in the Zoom, so I want to show in Paint. Okay. Okay, I will use my Paint instead of Zoom to share. Yeah, it's my screen. Okay, so the consequence of using look at here. Set, oh, it's differently. This one. Solid color. Okay. Set. Oh, how to draw it here? Oh, the size is too small. I use my here. Okay. Set. Ah, that's good. Okay. It showed us your hair. Okay. And now there are proton and electron. Okay. And this is your hand. Okay. You contact. This is your hand. I'm sorry, my drawing is not good. But look at. So when it interact with the electron from the hair, okay, afterward it make the electron, okay, repulse here, and the electron, because it is conductor, yeah, so electron
your hand.
will flow through your hand. So the electron will flow through your hand, and afterward, yeah, the electron for the hair contacted here, attracted by the steel. So afterward, the steel, after rubbing, still neutral. So a conductor means it just facilitate the electron to move without showing the electron and proton separations. So afterward, proton and electron in the end of the induction remain neutral. Yeah, remain neutral. Yeah, because conductor facilitate the electron transfer. Electron transfer means there is an electricity. A small amount of the electricity will flow through the conductor. Yeah, electrical conductor. Okay. Okay, before we continue to another discussions, okay, so I have the smaller view here, pretest, yeah, pretest. You can see the pretest and the link in Spada, yeah. Please answer the pretest by yourself. We will see the answer before we continue the discussions. Okay. Okay, how long, sir? We have a half hour. So you have a half hour, but if you have done your pretest, you can confirm me. We will discuss it. Okay, any questions? Okay, so now please fill the pretest in Spada. Did you get the problem? Okay, 3 students submitting the answer. Ilva and Fauzia getting almost perfect answer. Eight student enter. 9. Eleven student finish. Fifteen. 18. Now we have 26. Okay, 5 minutes before end. The student to complete. Semangat. Okay, every student have completed the answer. Thank you very much for your participations. Okay, you will see this is the distributions of the answer. Look at it, show normal. Look at the majority of the student getting the half answer. Yeah, means the question is good. Yeah. Okay, look at the average of student getting here 10.82. Yeah. So before we continue to the discussion of the answer, I would like to show some explanation from the video I have. So here is I show my screen one. Oh, share with the sound. Okay, starting here.
Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how electrons can be moved from one insulator to another if we rub them together, and that's called static electricity. And then go on to explain how there can be a force of attraction between opposite charges and a force of repulsion between two charges that are the same. Okay, take a look at this picture. This shows a child moving down a plastic slide in a park, and you can see that his head. So the question is, what is happening here? Static electricity, and this is what we're going to explore in this video. So first we're going to take a look at conductors and insulators. Okay, now metals are good conductors of electricity, and that's because electrons can easily flow through metals. Objects such as plastic and glass are insulators. That means that they do not conduct electricity, and that's because electrons cannot move through them. Now, a good example of an insulator is cloth. Like everything, cloth is covered with electrons, but they cannot move through the cloth because cloth's an insulator. So now I'm going to bring a plastic rod over to the cloth, and I'm going to rub the plastic rod with the cloth. Remember that plastic is also an insulator and is also covered with electrons. Now, if we rub the plastic rod with the cloth, electrons can move from the rod onto the cloth, and that means that the cloth has a negative charge. The rod is now left with an equal positive charge. So let's imagine what would happen if we did this again, but with a metal rod instead of a plastic rod. Well, if we rub the cloth against the metal rod, then electrons can move onto the cloth just like before. But metal's a conductor, so now electrons simply move onto and up the metal bar, and they neutralize the charge. So the metal will not have an overall charge at the end, and that's really important. So remember that static electricity only works with insulators and not conductors. Now, this shows you two plastic balls hanging on a string. This ball's got a positive charge, and this one has a negative charge. Now, opposite charges attract each other, so that means between these two plastic balls, and they move closer together like this. Now, if we have the same charges, then they repel each other, so two positively charged plastic balls would move apart. So let's go back to the question I asked at the start. What's happening to this child as he moves down the plastic slide? And why does his hair stand on end like this? Well, as he moves down the slide, the electrons move from the child onto the plastic of the slide. So that means that the child now has a positive charge. Because his hair is positive, that causes the hairs to repel each other, so they move further apart. Now, if this child touched a metal object, electrons would move onto the child to neutralize the charge, and his hair would return to normal. Okay, so hopefully now you can describe how electrons can be moved from one insulator to another if we rub them together. And then go on to explain how there can be a force of attraction between opposite charges and a force of repulsion between two charges that are the same.
Okay, so next here. The phenomenon of static electricity.
Cold cuts, no baloney.
Just science. Hi, I'm Joanna.
This is the example of another phenomenon.
PVC pipe.
Look at.
And this is a plastic cup that has a hole drilled into the bottom of it. So when I fill it with water, it leaks out of the bottom.
If I charge the pipe and then bring it close to the stream of water,
the
water is attracted to it.
Look at.
That's because water molecules are polar molecules.
Okay, would you please explain why the water attracted by the charge pipe? Would you please explain? Fauzia, are you there?
Yes, sir.
Okay, so why the water bended by the charge pipe?
Because the water is lower.
What? What? I didn't hear. I'm sorry.
Because the water, if I'm not mistaken, but I heard she said that the water is Polar.
Polar. Polar. Okay, what is the meaning of polar? What is the meaning of polar? Here, water polarity. It show polar. Yeah, it show a partial positive charge on the hydrogen and partial negative charge on the oxygen. So afterward, in the end, it show the electrostatic interactions when this polar molecule interact with the charge pipe. Okay, thank you. Yeah, okay, continue.
Water molecules look a little bit like Mickey Mouse. The two hydrogen atoms are bunched up on one side of the oxygen atom. And while the molecule itself is neutral overall, it has a positive end and a negative end because of the way it's shaped. Molecules like water that have an asymmetrical distribution of charge are called polar molecules.
Let's say the pipe has a negative electrical charge. If I bring it close to the stream of water, the water molecule flips so that the positive end is pointed towards the negatively charged pipe. Opposite charges attract, so the water is drawn towards the pipe.
This is an experiment you can do for yourself at home fairly easily. All you need to do is turn on the faucet so a little bit of water comes out. And then you place the charged object near the water. Any object that will hold a charge will do, like a comb.
Or a balloon that you've rubbed on your head.
Or a plastic pen.
Thanks for watching. Thank you. Yeah, okay, we will continue to see another experiment. Yeah.
Okay.
1,000
Let's go,
volt.
from a couple thousand volts to
1,000
half a million
volt.
volts. And that's what this guy right here is. This is a Van de Graaff.
Okay, see. Whoa. Wait.
Here we need Louis to give a little shake to that head.
What?
That's it.
Oh, nice.
Now, how much would Sherry
Right.
pay for that hairdo?
Big money.
Look at that. So there you see it, all the electrons trying to get away from each other, every hair trying to get away. Give us one more shake. There we go. All right, and if you don't have one of these at home, then you might have to just settle for the balloon.
balloon.
And that we have online. All right, Louis, stay up there. I'm going to power this off. And we'll film in. You want to film in on the website? And we'll
Sure,
like, clean
thank
up
you
here a
so
little
much.
bit. Very nice, Louis.
If you'd like to find out more about what
Yeah, so look at, I make sure the machine was turned off before, okay, the hand can be pulled out. Okay. That's another video I have here. What is it? Oh. Here. Oh, that's similar, I think. Okay, we will see another experiment. This is also another example. You can see it at school. Whoa. Have you previously created this equipment?
No, sir. No, sir.
Okay, so now it will be your experiment task. Okay, you can try it at home. Okay, you will see. Whoa. Interesting, right? Shoot. Yeah. Look. Yeah. Sad. Yeah, sad. Whoa. I have a kid, so I will apply it at home after my kids come from school. Okay, I've tried. Okay, showing this experiment, it will be interesting. It's so interesting. Try. So can fly. That's the final one.
excellence in science.
Okay, so after you have watched the video, would you please give me the example? What is the application of static electricity in life? In which case do you think that static electricity will be significant to your life? Please. Hello? Are you there? Why do you keep silent?
Hello?
Yeah, okay. So, Amri, please.
What is the question again? My connection is stable.
Okay. In which case static electricity will be significant to your life?
Static electricity would be significant to my life. I think it would be the case of safety in handling electrical appliances.
So, how do you handle the safety in static electricity?
I think by making sure that when you're handling electrical appliances, you make sure that you're not making a closed circuit so that the electricity could not flow through you, and that you should always wear some sort of insulator when handling it.
Okay. So, okay, thank you, Amri. Another example? Another example? Would you please inform me? Okay, Rahma, please.
Can be applied in photocopy.
Okay, photocopy printing. Okay, so how can it be applied in photocopy?
There's a tool that can attract the ink to the paper that we want to copy. So.
Okay. So please see. Okay. The example of static electricity. Okay, in photocopy. Yeah, photocopy printing. Firstly, the photocopy scan. Yeah, static electricity on the paper. Yeah, you copy and afterward printed into the printed paper. Okay. Next, another example. Have you learned with the LCD display?
Yes.
Do you use your phone? Yeah, do you know previously phone LCD display is touch screen, means the real touch screen. But now it's not the not the real touch screen. Yeah, it just you look like a rub. Yeah, your screen in your phone because of the electrical field on the surface of phone LCD. Yeah, in the phone LCD, it shows the electrical field contacted with your hand. So your hand can direct the operation of the LCD in the phone. Yeah. Okay. I'm sorry if you heard the dog sound here because there are 5 or 6 dogs in my neighbor. I'm sorry if this sound it will be yeah not make it here not comfortable. I'm sorry. Okay. So, oh yeah, my signal is poor. Okay, I have another example. I can show it to you. This one. Okay, here. Concept map. Yeah. Okay. Sorry, I would like to share my screen. Okay, this is our concept map. So static electricity, discuss first about the electrical charge. Yeah. So in which case, there are attractive force and repulsive force. So how does the interaction of inside attracted force? So there are a proton and electron, yeah, and the proton interact with the electron. So what will happen?
Attract each other.
Okay, so it will attract, yeah. So how do you estimate the magnitude of its attractions? You have proton, and this one is electron, and it was separated by the distance of r. Yeah, and we know, for example, it show two proton interact with the one electron, so it will show here the attraction, right? Okay, so this is one and this is two. Yeah, if we what represent it as F, yeah, attracted force, so we call it as 1 F 1 2 and 2, and this one show F2 2 and 1. So F1 2, it's different, it's negative. F2 1, because of the sign is different. Look at it, show its directions. The direction is right side, right? Look at this rightward and this leftward. Okay, so how do you calculate the force? So the force, let's show it. K, and then Q proton times Q electrons over the square of distance, right? Okay, this is the unit vector of force. So how do you derive the value of K? What is the K value?
9 times 10.
9 times 10 to the power of 9 Newton meter square times volume minus square. Okay, so how did it come from this K? This K, it's coming from here, this value, 1 over 4 P epsilon 0. What does it mean, epsilon 0? So it shows material permittivity. Okay, so what does it mean? Here, yeah, the force itself, it's not only affected by two interacted charge, so it will show charge 1 and also charge 2, but also infected by environment. Yeah, because look at the environment, yeah, while the charge stay on the air, so it show epsilon 0. But if I have two proton, this is a proton, I'm sorry, this one is electron, and it protected by the paper, by the paper here, so epsilon O will be higher. We call it epsilon R. Epsilon R here. So the unit of value K, if we apply with the paper here, it will be K of epsilon R. So K paper will be 1 over 4 epsilon R epsilon 0. Here. Yeah. So the value will be higher. Yeah. So it will influence. Yeah, influence the interaction between two charge. Yeah, two charge. Okay. So is there any questions? Remember, the charge of the proton will be plus 1.6 times 10 to the power of negative 19 coulomb. And the charge of electron is negative 1.6 times 10 to the power of negative 19 coulomb. Okay. So if we have applied another charge in this side, so look at, it will show 3 as we know. When it interact each other, so it will be got the repulsion force. So this is F2 toward F1, sorry, F1 toward 3. So if you want to estimate the total force, you will get the force resultant. So the force resultant will be consists of F1, 2, yeah, I, okay, this show I, okay, minus F1, 3, J. Okay, so remember this is I axis and here J axis. Yeah. Any questions? Okay. We will continue into the explanations of the static electricity here. Oh, how to show the slideshow? Why it can share? Sorry. Oh, here the slideshow is over there in the screen. Two here. Okay, please wait a while. Okay. So I will present my material here. Whoa. I share with the sound. You like sound. Look at. Sorry. Okay. To kind of the charge, yeah, as you remember. Okay. Rules carry electric charge. It exert electric force on the paper. Yeah. So charging by the frictions, so call it as electrostatic. Yeah. As we know, the charge itself or the electron turn. Yeah. So it turns the nucleus. Okay, we have proton and the neutron is neutral and also electron. Where did charge come from? Okay. So if the total number of the proton the same as the number total of the electron, so the material will behave the neutral charge. Okay. When the electron gains, more electron, so it shows negative charge. If it shows more proton losing the electron, so the material will have a positive charge. The question is why the electron move, not the proton move. Would you please give the reasons?
Because the proton is in the atom, sir.
Okay, because proton is located in the nucleus. Okay, that's one of the reason. Another reason also you can relate it with here. The mass of proton compared the mass of the electrons. Yes, I have mentioned it before. Do you remember? The mass of proton since it approach what? 1. Okay, so I need my whiteboard. Yes, I have to share my whiteboard first. Okay, so do you remember the mass of proton? The mass of proton is 9.1 times, it's 1.67 times 10 to the power of negative 27 kilograms. Mass of electron means 9.1 times 10 to the power of negative 31 kilogram. Yeah. After completing this electricity and magnetism, you remember, yeah, how heavy the proton and the electrons. So you can compare it. 1.67 times 10 to the power of negative 27 over 9.1 times 10 to the power of negative 31. So if we compare it each other, okay, the proton was 1835, okay, heavier than the electrons. You can imagine, for example, if yourself has 67 kilogram, that's me, for example, times 67. So proton look like a car or a train having 123 tons. Look at. So if it is you, yeah, and we know a train, train, yeah, one train, it has 32 tons, yeah, so over 32. So it's similar to almost similar to 4 trains or 4 bus. Whoa. Okay, if it is you, okay, it's look like you are interact with the 4 bus. Yeah, so this is the comparison between electron and proton. So proton stay on its positions while the electron are moving. Yeah, easily to move because it 1,835 lighter than the proton. So electron will easy to move compared to proton. Yeah, is that clear? Okay, can you understand the reason?
Yes, sir.
Okay, so I'll continue to another discussions. Okay, screen 2 here. Okay, so look at in chemistry. Do you remember electronegativity? How about the electronegativity of the material? We have group 1 until group 7. So how the order of the electronegativity? Do you remember? In periodic table?
Yes.
Electronegativity in periodic table. Yeah. So when 2 materials interact with each other, so it follow the electronegativity of the material in case the material just 1 atom. Yeah. But if you see it more than 1 atom, so it depends on what experiment we apply. So look at, for example, we simplify it for general high school context. Yeah, for example, we have a glass and also human air. When a human air, rub by the glass, so glass will have a tendency to get a positive. Okay, so human air will be negative charge. Yeah. But when the human hair, contacted with the aluminum or the paper, so paper will have a negative charge after rubbing, while the human hair will have positive. Means the electron from the human hair, jump, transfer through the paper. For example, another conditions, for example, silk. When the silk interact with the PVC pipe, so PVC pipe will got negative charge. Yeah, because the electron from the silk transfer to the PVC. Yeah. So another example. So what happened if the cotton interact with nylon? So would you please, one of you, explain the answer?
May I, sir?
Okay, please, Dicky.
Cotton and nylon, right?
Yes, cotton and nylon.
the cotton will remain in negative charge while the nylon is going to be in positive charge because the electron in nylon is going to the cotton.
Okay, thank you. Okay, Diki. Another sample, rubber with PVC. So what will happen? Want to answer?
The rubber would be positively charged, while the PVC, I guess, is going to be negatively charged.
Okay, thank you very much, Amri. Yeah, so that's the right answer. Okay, so we continue to another way. And you can see also the order of the electronegativity in the material in case there is not listed in the order of here electronegativity here. Yeah, okay. So you can see it in the periodic table as we know. Yeah, the right side will have a tendency to become a negative. Yeah, to become a negative compared to the left side in the periodic table. I'm still searching here. Okay, here. This one, look at. Yeah, so the trend of the electronegativity of the material in the periodic table. So, wait, blank. So waiting for here. Okay. Set, enter. Okay. While waiting, I will continue to another discussion here. When a balloon rub a piece of the wool, yeah, okay, just the example I have. Okay. Here is the trend, look at electronegativity increase. Yeah, so in the right side, the electronegativity increase. Yeah, from upside here, the electronegativity increase. Yeah, when it decrease into left side and downside. Yeah, so leftward and downward, it will decrease the electronegativity. Yeah, and then upward and rightward, it increase the electronegativity. Yeah, for example, when the oxygens interact with the nitrogen, which one will become positive and which one will become negative? When the oxygen interact with the nitrogen, what will happen? Which one is positive and which one will be negative?
The nitrogen is positive and oxygen is negative.
Okay, thank you. That's good. Yeah, so that's the right answer. So electricity also relate with electronegativity. Yeah, and also please remember when there is a conductor, material allows electron to flow through them easily. Okay, this the example I have a metal, and remember when metal interact with the ground, so ground means it has a high electronegativity, so it will be easy to receive the electron. So that's why I call it as the ground. Yeah, to save the earth. If there is no ground, so the earth cannot protect the people standing on the earth. So earth save everything. Yeah, it's not only water but also electricity. So this is a paper. Okay, so I think this example. A balloon has a negative charge when rubbed by the woolen cloths. So what is the answer? Do you remember? If balloon can attract some paper scrap, which of the following cannot charge of the paper scrap? What is the answer? Sir, I don't know. I forgot. Negative. Okay. So another question. Balloon has negative charge and rubbed by woolen cloths. Which one? Electron, proton, or neutron?
Electrons.
Okay, excellent. Okay. When a positive charge rod is put near the neutral object, blah, blah, blah. Can you please fill the answer? What can we input?
Proton.
Negative charge. Negative charge. Okay, yeah. In the side of the object. And of course, it will be positive. Rod can attract a neutral object because attraction between rod and negative repulsions. Yeah. Okay. So this is the example when we are grounding. So the grounding will make the electron flow from the ground to neutralize. Okay, to neutralize the charged metal. Yeah, that's the fact. So finally, metal ball become neutral. Yeah. So the electron flow from the ground to the metal ball. Next, what will happen if we have a negatively charged metal contacted with the ground? So the electron will flow through the ground. Okay. Another, why do gasoline tanker usually have metal chains at the back? Have you ever seen? See it? Gasoline tanker. Pertamina. Pertamina truck. There is a metal chain at the back because you know the metal can facilitate the electron move from the tank to the ground. Yeah. So you can imagine if tanker gasoline, yeah. Of course, you know a tire is made of what? Rubber, right? Okay. And finally, you know the tank will be charged, and we know when the charge transfer to the other will result the spark. The sparkling will
produce fire.
Yeah, so it make it fire to the tanker. So a tanker should be saved. So it contacted by the metal chain, the brake. Okay, so that's the thing, but we have never investigated previously. Yeah, so you will be aware after studying static electricity. Okay. So look at it. Show when a car run a tire, we got the friction. So it look like what inductions, and it will result the spark, and it will produce the explosions. Finally, the tank must be grounded to avoid the danger. Okay, that's lightning. What will happen if, as Abi said, that during viewing the lightning, we'll see that lightning. Yeah, the appearance will be seen it previously and followed by listening the sound of lightning, right? Because of the speed is different. And you know, during lightning, okay, so why the God, okay, would you realize why the God create the lightning? Is there any purposes of the lightning? So after studying the static electricity, you will realize that the God has a good plan so that it will save the environment by lightning. So what is the purpose of the lightning?
Is it the symbolic purpose or actual purpose?
Actual purpose, this scientific purpose. So afterward, you will be aware that, wow, subhanallah, yeah. So how do you, how deep you understand the lightning? What will happen if there is no lightning? Hello. Who is the General Secretary SAIPSU, is it?
Deaser.
There.
Okay, I lost my connection first. Okay, we continue the discussions. So what is the purpose of lightning? Please, would you please share me?
From what I've read, lightning provides
What
source
do you know?
for phosphorus on Earth, and also that without lightning, basically that the balance of electrical charge between Earth and atmosphere will just disappear.
Okay, so there's one purpose because of lightning. So it reduces the voltage across atmosphere and the ground. Okay, another purpose of lightning, you know.
From the source that I have, it say that the lightning can make the ozone layer thicker, but I don't know how it works.
Okay, so lightning create the ozone layer because during lightning, it break off the oxygen become O2 minus, O2 minus, and it create the ozone layer. Another purpose of lightning, ozone layer, we know it can save the earth, right? Okay, Ilva, what do you mean? The purpose of lightning?
Dissolve the unusable nitrogen in water, sir. So
okay, that's very good. Yes, so it dissolve nitrogen in the air. So because you know, plant needs ammonia, right? Plant needs ammonia. So nitrogen in the air can broken up by lightning. So during lightning, it can break the chemical attractions between two atoms of the nitrogen or two atoms of the oxygen having two bonds. Yeah, so it can break up. So afterward, it can form another chemical reactions during lightning. Yeah. And also due to the lightning, you know, there will be a rain. Yeah. Without lightning, there will be no rain. Yeah, because rain needed to be shake first, and afterward, it look like what a stone in the air. It shake, and afterward, form to the smaller particle for the precipitation, right? Okay. Another, can I, yeah. Sorry, what will happen? It cannot be operated. Oh, here. Wow, which cloud? Judge. Wow. Whoa. Okay. Yeah, you have to be aware during raining. Please do not approach the tree. Yeah, because the tree will have a tendency to catch by the lightning. Yeah, be aware. Yeah, and also when you are wearing an umbrella, right? And also there is no higher level. Yeah, for example, you are in the rice field. You are in the rice field, and in accidentally there is a rain and it show lightning. So be aware. Yeah, yeah. Please, you just on your house, yeah, or in saung, yeah. So will be safer. And then you are stand up on the rice field, yeah, alone. Yeah, okay. So it will be dangerous for you. Okay, here, okay, so I think generally the scope of the material have been explained to you. So now is the time. Do you need the free time? So we'll have 5 minutes, yeah, to get relaxed. Okay, so afterward we will continue to showing you your pretest answer. Yeah, it's okay. Okay, that's we see it at 9:55. Okay, Assalamualaikum warahmatullahi wabarakatuh. We continue discussing the answer of the pretest. So you will see that 78, yeah, it's coming from another batch also, not only the batch, your batch, sorry, your upper batch. So here we see the question first. The question, here is the questions, and we'll see the answer. So number 1, okay. So look, the question number 1, as I have discussed previously, yeah, from these sessions. So negatively charged rod is held close to one side of the metal sphere. The other side of the sphere is earthed. Which diagram show the distribution of the charge on the metal sphere? So the answer is number D. Yeah, because you know, proton and electron will be easily to interact. Yeah, so it will be approach electron and proton. Okay, so where is annotation? I need the annotations. Have I shared my screen? Oh, no. I'm sorry, it's not yet. So I explained, but you mudeng. Okay, you'll see here. Share screen here. Yeah. Oh, I'm sorry. It just applied to screen. Screen must be adjusted for my here. I set the screen for my pen. So work area. Set apply. Okay, thank you. Now I can use my pen in the second screen. So look here, it interact each other, right? But this, in fact, it's ground. As we know, in the ground, electron will be easily to transfer to the ground. Yeah, remember? Okay. And also here, it's not fair because there is no proton of this, and also this, the proton is not distributed here because it interact with the electron. Okay, is it clear? Can we continue to another discussions? Okay. Okay. Oh, where are you? Okay. So, but now I didn't see your appearance. Where are you? So, okay. Oh, yeah, now it's technical. Oh. Okay. So let's look another answer. Number 2. Whoa, look at number 1 and A and B is answered almost similar. So look, what makes it different? Look at positively charged plastic rod is placed just above a thick metal plate. The metal plate rests on an insulator and is connected to the earth by the wire. Students disconnect the earthing wire and then remove the positively charged rod. Yeah, you know, that's insulator. It will make the material charge here. So, but also, you know, it show here as metal plate. Metal plate means it will facilitate the electron to flow. Yeah. So when the earth wire disconnected first, metal plate become negatively charged. Yeah, because it show positive. Yeah, so now it's negative here, negative. Yeah, when it's connected to the earth wire, we know electron from this will transfer to the ground. Yeah, because it's positive interact with negative interact. Okay, is it clear? Okay. Is there any questions? Okay, no questions. I can continue to another answer. Oh, drawing and stop annotation first. Continue to the number 3. This number 3. Okay. Diagram 1 show a thin charged strip of plastic. Okay. And afterward, it rubbed by the dry cloths, and afterward, okay, the strip of plastic repel each other. So what's the answer? B. Yeah, it's make it clear, and it's no need to me to discuss it a lot. And now number 4, we see also the number 4, the answer. Wow, number 4 also similar. Yeah, it's repel, okay, because it show both plastic rod, because it show the same material near X, near Y, it will be repel. Yeah, because the charge will be similar when it made of the same material. Number 5, a plastic rod is rubbed into the cotton cloths. Remember the order of electronegativity of the material. Yeah, so which row compare charge of the rod and the cloths describe the effect of direction between rod and cloths. Yeah, charge on rod becoming positive, so afterward it can attract because of a charge difference between rod and cloths. Yeah, okay. As long as it show a different material, basically it will be attracted. Yeah, if a material interact with the same type of the material, yeah, it has a tendency to be repelled. Yeah, if two material having a different made of a different material, yeah, two things made of a different material, so it has a tendency to get the attractions. Yeah, and now number 6. Yeah. You see number 6, B, the answer, glass rod and the plastic rod. Yeah. With rubber plastic still available. Okay. Okay. Number 7. Wow, majority is C. There is no need to me to discuss it a lot. Number 9 also similar. The answer is B. Okay. That's not a good question. Means the question is not valid. It must be removed. Remove. The good question is here. Look at majority of students answer it. All option were answer. So that's a valid question. It's a good question, and afterward it can distinguish the student having a good score and low score. Look at, because the majority of the correct answer can be answered correctly here, 25, but all the choice also answered by all the students. So this is the type of the valid questions. That's the good questions, but it's not good for the student side. Because it make it too hard. Because look at, it's only a 32 but a question answer it correctly. 32 student answer it correctly. Number 9, so that's a good things I have. It show the answer is C. Yeah, similar thing.
I'm sorry,
okay.
Sir, I have not share screen.
Oh, astagfirullah. Thank you for reminding me. Okay, this here. This is the example. It's a good questions. Yeah, and number 9. Yeah, the majority of the student answer C, means it's the correct answer. No need to discuss it a lot. Now number 10 also the same thing here. So majority of the student answer B. Yeah, so downward and upward. Yeah, in terms of the direction of electrostatic force due to a different sign of the charge. Number 11. Yeah, as we know, we have two balance because it shows the same material, and when it inducted by the charge, it will be repel each other. You'll see number 12. Okay, number 12. B. Yeah, the balloon, rod and balloon carry like a charge. Yeah. As long as the material made of insulator, so it will be easy to save the charge on the surface of insulator. Oh, that's enough. 12. Yeah, 12 question. But now here. Okay, sir, which one? First, look at the order. F1 greater than F3, greater than F2. Okay, would you please, one of you, give me the analytical answer of these questions? Who want to share your answer to me? The answer of SI questions here.
May I, sir?
Okay, I allow you to share the board. You can share your board. You can share your whiteboard. So give the analytical answer of these questions.
May I start, sir?
Boleh nilai bang. Okay, so please just censor it. Okay. Ilva, okay, just continue to share.
Okay, sir. But I don't know if it's right or not. So for the first picture, how it's
Okay, can you draw? Do you have do you use mouse or you use a pen?
I use pen.
Okay, yeah, just
I don't have mouse.
just draw. Yeah, just draw it, please. Or if it's too hard to type, maybe you can share me on the paper writing on your hand. Maybe it will be difficult. Yeah, you can take a picture of what you have answered it and a piece of paper. So you just share us what you have written on the paper. No need to draw it from the beginning. Okay, that's good. So look number 1. Okay, so we will see the position of the electron. Okay, so D 1 4. Okay, very good. Number point 1, it's correct. And that we see number 2. Okay, the electron is located at the center. And afterward, F net will be Q1 and minus Q2, right? Okay. Okay, 0.75. Yeah. Okay, good. But the result should be Kp square. Yeah. So look at sorry, P. Oh, maybe here. What I mean, look at not K, Q1, Q2. There is no Q2. Yeah, E. So maybe K, Q1, E. K, Q2, E. Yeah. So if Q1 and Q2 is the similar P, but you need E. So 1.25 K P E. E, yeah. You lost E. Pak. Do you know what I mean? Because force include K, Q1, and Q2, right? Q1 in terms of proton, Q2 in terms of electron. So the result may be here. K, P, E. Yes, E here. E. E, K, P, E. Here. Yeah.
Okay, sir.
Okay, so next, number 3. Number 3. Okay, good. And afterward, you order it. Okay, 1.25 greater than 1.03, greater than 0.75. Okay, very good. Thank you very much, Ilva, for sharing your experience. Okay, I think that's all. I believe everything for this purpose have been explained it to you. But now it's time for you to complete another experience on SPADA. Yeah, in SPADA there is a group assignment. Yeah, the group assignment of the theoretical questions. So theoretical questions can be done in the group. Yeah, theoretical questions. So static actually experiment. Yeah, prospective at home. Yeah, maybe you can create like a project on static electricity. For example, a rubber. For example, making what electroscope. Yeah, as long as it can be done at home. You can present it. Yeah, present it in a video. Within a video. Do you have here, right? Do you have a YouTube channel?
Yes, we have, sir.
Okay, so please perform one example of a static electricity, record it in the video, within a video, and then publish it in your YouTube channel, and send the link through the task of here, experimental activity. So we have experimental work and the theoretical work. So experimental work relate to the activity you have done at home. Yeah, at home in terms of the available equipment. Yeah, so no need to you to prepare what I mean an expensive material to perform one of the evidence of static electricity. Just select one of phenomenon of the electricity you can perform at home. Yeah, and submit the link submit the link of your work through experiment activity or project on static electricity. Okay, is it clear? So you have two tasks. First, regarding theoretical assignment, yeah, to review the understanding the concept of static electricity. Secondly, perform one project in terms of the static electricity available at home. Yeah, put in your YouTube channel. You can make like a playlist. Inside the playlist static electricity, so it will be meaningful for people around the world to watch your video, your activity. Yeah, one example. What should you do? Like Yeah, open up, and then within 3 minutes is enough, I think. Yeah, no need to make it too detailed, but at least one phenomenon can be shown by yourself and explain the reason behind it. Okay, I think it's enough. Is it the what team group task? No, it must be the individual task. Yeah, individual task, because we cannot join in the group for practical work. Yeah, but for the theoretical work should be okay. But for the experience activity, maybe should be better. You can try your own experience in static electricity by yourself. This is what I recommend, because in the future you will be a teacher at school. So your experience will be meaningful to show it to the students. Okay, can you listen my voice? Maybe I have a trouble with my signal because I'm freezing.
No, sir. It's clear enough, sir.
Yeah.
Okay, thank you. If it is clear, another question maybe can be addressed before we end up the class. Not yet.
Sir, it's about the due date or deadline in SPADA. It's not
Oh, available. Okay, so we will set. So the okay. Okay, so I will set the due date in SPADA. Yeah, thank you, Sofa, for reminding me. I will set the SPADA after this. Okay, so if there is no further ado, maybe we can end up the class. Yeah, thank you for your participation today in the class. Maybe this class will be meaningful for each other. I hope this material will be, beneficial for your future work as a science teacher. Yes, so we say hamdalah, alhamdulillah alamin, and praying to Allah subhanaka Allahumma wa bihamdik, syahadu alla ilaha illa anta astaghfiruka wa atubu ilaik. Billahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh, sir.
Thank you. Thank you.
Ya, yuk. Ya, salam ya buat keluarga di rumah.